We're going to talk today specifically about function notation and variable dependence and talk about inputs and outputs for functions. In order to describe functions and function notation, I'm going to use a linear model here. This is a relationship between two variables. In this case, it's t and c. I'm going to say the context for this is that c is the cost of a repair, let's say a plumbing repair, and t is the amount of time the repair takes. In this linear relationship, 60 would represent a fixed cost, or let's call this the service fee for the repair. The 50 would be the variable or the rate of change. In this case, that would be the cost is $50 per hour for a repair. We can represent the relationship between two or more variables as an equation, as a table of values, or we can represent it graphically. There is no one specific solution to this type of relationship. The value of C, or the cost of the repair, will vary based on how long the repair takes. You'll see some examples here and graphically represented over there. The concept of functions is not really a radical change or a new type of equation. Instead, it's a different way of looking at the relationship between the variables. In this case, what we're going to do is declare that t is the independent variable, or the variable that changes naturally, and c we're going to call the dependent variable, because the cost depends on the amount of time for the repair. The way that we declare this relationship is by putting this notation next to c right here. So we're going to put a parentheses t after c. What that represents is that the cost of the repair depends on the amount of time taken on the repair. Importantly, this notation, c of t, does not mean c times t. What this means, it's telling you that the variable c, or the value of c, depends on the value of t. Or in our context, the cost of the repair depends on the amount of time on the repair. Now c and t mathematically have very specific roles. T is called the independent variable, and c, which depends on the amount of time, is called the dependent variable. As we move forward, another way of talking about independent and dependent variables, we think of independent variables as inputs, and we think of dependent variables as outputs. Mathematically speaking, functions are mathematical objects that relate to or more variables. In this case, we're relating the variable t with the variable c. We will input information into our mathematical machine and we output information. In this case, we're inputting time for repair and we're outputting cost. With this notation, we can ask questions like this. Find c of 3. What this is asking us to do is to input 3 for the independent variable, or t, and find out what the cost is. To do this, what we're going to do is simply plug in 3 for t and evaluate this. When we do this, we'll get 150 plus 60, which is 210. This is a really important part of the notation, and I want to link it to the table and the graphical representation. This means if we input for t a value of 3, we get 210 as an output. This statement right here as it sits, c of 3 equals 210, is exactly the same thing as this line in the table of values. And it's also exactly the same as this point on the graph. To tie that last example together, let's look at another one. For instance, if I wanted to find, let's say, c of 2. What this is looking for is what this function outputs when I plug in a 2. I could do that two different ways. I could go to the table of values, find my input or my t value of 2, and find out the associated cost is 160. So that would give me that c of 2 is 160. Another way I could do that is graphically. Graphically, I could go to a t value of 2 here, find out where this value intersects my graph, and find out that this outputs a value of 160. It's really important to understand the link between all of these versions. The function notation, the original equation definition, the table of values, and the graphical representation of functions. So far, we've just plugged in inputs into our function. We actually can ask questions like this. Find t such that c of t equals 110. In this way, we're asking for what input value or t value do we plug in to get an output of 110. And we can do this both graphically, both with the table of values or with the function definition here. If we want to find the t value so that c of t is 110, we look at this line in the table of values, find this output of 110, and say that's associated with the t value of 1. Alternately, what we could do graphically is look for when the output is 110 and find out that that's related to an input of t equals 1. Finally, the most common way that you'll solve a question like this is simply set your equation equal to this value, this output of 110 equals 50 t plus 60. We're simply going to solve this for t by subtracting 60 to both sides to get 50 equals 50t, divide by 50 to get that t equals 1. Finally, functions don't really introduce too much new mathematically as far as equation types to mathematics, but they are a really important way of looking at them. Functions will have very important concepts like domain and range that you'll be introduced to, and the important concept that for every input there's one unique output that we'll cover in a different video. But I want to leave you with one last traditional image of functions. Functions are a mathematical machine. We think of these as machines that take in specific inputs and give us out some specific outputs. Again, for instance, if for this function right here, if we input the value of 3 into this machine, this function right here, it will output the value of 210. The first important thing when dealing with functions is simply getting used to this notation and understanding what it means.